Hi everyone, Dr. Jyotsna here. Let's talk about IV fluid. We all know that this is the commonest and most used prescription in the ICU, but where does it go when we administer it? So let's know about the total body water distribution. So we all know that extracellular volume is one third of the total body volume and two-third is the intercellular volume. Out of this one third of extracellular volume, three-fourths remain in the interstitial space, whereas only one-fourth goes to the intravascular space, and which is responsible for our blood pressure and all the nutritions and everything which is distributed throughout our body. So let's know what happened to which fluid when we administer, where which fluid goes and how much it goes. If we are using any dextrose containing plain solution like D25, D5, D10, the dextrose part is get metabolized and what remains behind is just water. So this water is distributed in the same way as the total body water in our body. The same way, intracellular volume there will be two-thirds of the total the IV fluid we have given, the dextrose containing IV fluid we have given, and the remaining will be go in the extracellular volume, that is one third. Out of this one third, the three-fourth will go to the extra interstitial volume and one-fourth will remain in the intervascular volume. So suppose we have given a 1 liter of D5. So in this D5 will get dextrose will get metabolized and the remaining 1000 ml of water will distribute in the same way as the total body water, that is one third, that is 333 ml of the 1000 ml will go in the extra cellular space and the remaining 667 ml of the 1000 ml will remain in the intercellular space. So now this extracellular volume, this volume will further distribute in the interstitial volume in the same way as the total body water composition. That is one-fourth will go in the intervascular space, that 83 ml of 1000 ml, and three-fourths will go in the interstitial space. So that will be 250 ml of the total 1000 ml. And if we are using any isotonic solutions like it RL or NS or Carbolite or any such isotonic saline, that remain confined to the uh, in extracellular space. It doesn't goes intracellularly, so it doesn't causes cell swelling. So it remain in the extracellular space, but yeah, it goes in the interstitial space as well. So in the same way, out of 1000 ml, the one fourth will go in the one-fourth will go in the intervascular space, whereas three-fourth will be in the interstitial space. Means out of 1 liter, 750 50 ml will be in the interstitial space. Only 250 will remain in the intervascular space. Means 1 liter of NS I have given or 1 liter of RL I have administered to a patient, only 250 ml is in the intravascular space. So this only it is this much is it is contributing to the intravascular space, and the BP will rise accordingly. And suppose we are using half NS or half of so it will be just half. You can just take it divide it 250 by 2 and 750 by 2. So that will be the amount of the fluid it remain in the intravascular and interstitial space. Now come to the colloid. Suppose we take 25 gram of colloid. So what happens, colloid remains in the intervascular space only, and it withdraws the fluid from outside. And suppose 25 gram of albumin will withdraw a 450 ml of yeah, fluid in the intervascular space. But yeah, As we know, the albumin has a limited half life, so so for that many days only it will remain in the intravascular space. But above all, we should know during inflammatory stage, the permeability changes, the protein level changes. So then the leaky capillary can the distribution of these fluid can change. Thank you.